Oh, actually, I'm just gonna end up cutting all this out, of course. All right, I gotta do that every time to set the audio. Make sure everything's in sync. Well, welcome to your Wednesday Math Minute, the only Math Minute guaranteed to be on Wednesday, and guaranteed to be no more than 10 minutes long. There was apparently an issue with last week's Math Minute. Somehow in the upload, it ended up 30 seconds too long. I'm not in charge of that. I can't speak to that. But I will just say, you definitely, will get your money back. Comment down below, like and subscribe, and for sure, you'll get all the money you paid for this video. I'm so excited about today's Math Minute. I've been thinking about it all weekend long. And I know I'm not going to have time to do everything I want, so I'm going to split this up into two for the price of one Math Minutes. And again, the price is free. I want to look at some distribution math tricks. So here's what we mean by a single distribution trick. Let's say I just wanted to quickly do this mentally, right? I'm not going to do this with a calculator. I'm going to say this is 781. This is 913. 1045. 253. 594. 517. 92. 429. 792. 143. 275. Oh my gosh. 1010. And finally 858. Okay. How did I do that? Right? What am I doing that I can multiply? Now, 11 is not the hardest thing in the world to multiply by, but what's going on? Let's take something, let's do a couple of these simpler ones. Maybe from the choices I'm making, you can actually kind of tell what's going on here. So let's start with something like 23 times 11. Now, last time I talked about the distributive property, and if we can take something like 11 and think of it instead as 10 plus 1, then hopefully you can tell what's going on here is in my head I'm essentially doing 23 times 10 plus 23 times 1. Now, of course, 23 times 10 is 230, and 23 times 1 is 23. And so really all that ends up happening here is I'm going to take the number, add a 0, and then add that back to the number itself. And so that's where I'm getting something like 253. Now, in practice, that's not how I end up doing the trick in my head. What I end up doing in my head is I say, oh, the ones digit of 23 is going to come down here and be the ones digit of my answer. And then I also know that I'm going to take the sum of the 3 and the 2. In other words, the sum of the ones digit and the tens digit. And then finally, I know that I'm going to carry whatever the tens digit was of the original number down as the hundreds digit. And so that's where the 253 is coming from. This is what we would consider a single distribution trick. Again, to take another example, say 54 times 11, I'm really thinking of this as 54 times 10 plus 1. And I'm distributing that 54 and doing 540 plus the 54. And again, now I can see pretty clearly, oh, of course, that's going to be 594. And again, you can see the 4 from the original number getting carried down, added to a 0, nothing happens, stays a 4 in the ones digit. And then the tens digit and the ones digit together, right, end up making that 9 in the middle. And then, of course, my tens digit becomes the hundreds digit when I multiply by, 54 times 10 right there. And so that's where that 5 is coming from. This time I'm not going to write all the work down. I'm just going to write the digits down as I go. I start with my ones digit. I add the ones and the tens together. 2 plus 7 is 9. And then I rewrite the tens digit, 792. Write down the ones digit, add the 1 and the tens together, rewrite the tens. Every time. This is how you multiply things by 11. Write down the ones digit, add the 1s and 10s together, write down the tens digit, 275. One more. Do this one on your own for a second. Think, think, think. I said think. Okay. Write down the ones digit, add them together, rewrite the tens digit. Now, some of these don't end up looking that way, right? Like 813, I haven't rewritten the tens digit. At least it doesn't look like I've rewritten the tens digit. So what's going on there? Let's consider 11 times 83. Now again, if you just think of it in terms of your distribution, this is going to be 83 times a 10 plus a 1. So again, that's 83 times 10 plus 83 times 1, or 830 plus 83. Now some things will be the same here. My ones digit still ends up getting carried all the way to the end, and I just get that 3 out there. But now I'm going to have to take the ones digit and the tens digit and add them together, and they're bigger than 10. So I end up with a carry. If I were drawing this out the way we normally do, our stacking algorithm for addition, right, 830 plus 83, I would see the 3 come down here, and then the 3 plus 8 makes 11, and I carry, and then I write down the 9. For the purpose of the trick down here, I'm just going to write down the ones digit of whatever that sum is I just came up with. 8 plus 3 is 11, so I write down the 1. And I'm just going to remember I've got that 1 to carry in my head. Normally at this stage, we just took our tens digit, and that became the hundreds digit of our answer. And so I would write down the 8 here. But I'm not going to write down 8 because, again, I have that carry in my head of 1. And in fact, you can see over here, that's why we end up with a 9 in that position. So that's exactly what I'm going to write down, 913. So just a little bit more complicated. We do have to do a bit of carrying in our head, but not super difficult, right? Let's do a couple other examples from over here. So again, here's the process, very similar. Take your ones digit, write it down, always. So that's easy enough. And then take your ones digit and your tens digit and add them together. 9 plus 5 is 14, but we're only going to write down the 4 of the 14, and we're going to carry the other one in our head. And then finally, I'm going to take this tens digit here, which is 9, but I'm going to add that carry that's up in my head. 9 plus 1 is 10, and so we get 1,045. Did I actually get that right on the other page? Yeah, of course I did. What was I worried about? Let's do it again. 11 times 39. We start, of course, with our ones digit, which is 9. We take the ones digit and the tens digit and add them together. 3 plus 9 is 12, and I carry the 1. And then finally, we want to take our tens digit, 3 plus that carry of 1 makes 4, and so 429. Take a moment and work out 11 times 78 on your own. The girl from Ipanema is calling. Okay, so I have an 8 from my ones digit, right? And then 8 plus 7, the ones digit plus the tens digit is 15, carry the 1. And then finally the tens digit itself, 7 plus 1 makes 8. And so that's 858. Did I get that one right too? Yeah, of course I did. Do I want to show you one more? Just in case I have time, or maybe this is going to end up being tomorrow's Math Minute, consider another trick called the 101 trick. Let's say I wanted to multiply 101 times any two-digit number. Let's do, say, 27. It really doesn't matter what the two-digit number is. This is, of course, the same thing as 100 plus 1 times 27, which I can then distribute over here, and I get 27 times 100 plus 27 times 1. Now, this is even better than the 11 trick, because as long as it's just a two-digit number times 101, we're never going to end up with any carries. Because, of course, 27 times 100 is just 2700. 27 times 1 is just 27. And so my answer simply ends up being 2727, 2,727. And again, this works for any two-digit number you want. So let's see. Magic. Wait, is that good enough? Magic. Here it is. So let's say I want to do these real quick. Again, 28 times 101, what I'm thinking in my head is, oh, that's 2800 plus a 28. And so I'm writing down 2828, right? So I think this trick you can get the hang of pretty quickly, right? 73 times 101, give it to me. 73 73, 54, 54, 82, 82, 97, 97, 18, 18, 35, 35, 42 times 101, 4,242, and so on. We call these single distribution tricks because I only take one of the numbers and split it up, right? I only took the 101 and split it up into 100 plus 1. I only took the 11 and split it up into 10 plus 1. There are other single distribution tricks. There's a trick based on multiplying by 12. Those are the ones I'm familiar with, but you can invent as many as you want. But really the fun starts with double distribution tricks. So I'm going to try to get to double distribution tricks in tomorrow's Math Minute. But that has been your Wednesday Math Minute, the only Math Minute guaranteed to be on Wednesday and guaranteed to be no more than 10 minutes long. I hope it was helpful for you. Goodbye.